Exercise 1.1 of Class 12 Ncert book. Questions on reflexive, symmetric, transitive, and equivalence relations. Show that the relation R in the set of all triangles. Let's have a set of many triangles. These are all various types of triangles. But in this set, some relation is defined. A triangle T1 will be related to triangle T2 if T1 is similar to T2. Let's see. Here, similar triangles. Of course, many are related to each other. This T8 will be related to T10. They are looking similar. But T9 cannot be related to T5. They are not similar. For them to be similar, all three angles should be equal respectively. Or the sides should be proportional. Now, let's see whether this relation given to us is an equivalence relation. To check whether it is an equivalence relation, let's see whether it follows the condition of symmetry. For the relation to be symmetric, every element of the form A, A should belong to the relation. That means a triangle should be related to the same triangle. Yes, it is correct. Since every triangle T is similar to the triangle T itself, we can say T, T belong to R. Therefore, the relation is reflexive. Every element is related to the same. So, reflexive relation. Now, to see whether it is symmetric relation, whenever there is a triangle T1 related to T2, we should be able to say T2 is related to T1 also. Or in other words, if T1, T2 pair belong to the relation, then T2, T1 pair should also belong to the relation. Let's see, is it possible? If T1, T2 belong to the relation, T1 is similar to T2, which implies T2 is similar to T1. That means T2, T1 can also belong to the relation. Look at the logical way of proving it. Whenever there is a pair T1, T2 is in the relation, that means T1 is similar to T2, which means T2 is similar to T1, that is T2, T1 also belonging to relation. Hence, the relation is symmetric. Now, to check whether it is transitive, let's take for two pairs. Let T1, T2 and T2, T3 belong to the relation. That means triangle T1 is similar to triangle T2, triangle T2 is similar to triangle T3, which implies triangle T1 is similar to triangle T3. Therefore, pair T1, T3 will also belong to the relation, which is what we want to have to call a relation transitive. Whenever the pairs of the form T1, T2 and T2, T3 are there, having the T2 common, the pair T1, T3 is also found, logically proved. So, the relation is transitive also. And if a relation is reflexive, symmetric and transitive, that is called an equivalence relation. So, this given example, it's an equivalence relation. Further, we are given three triangles here. Triangles with sides 3, 4, 5, 5, 12, 13 and 6, 8, 10. Of course, we observe all of them are Pythagorean triplets. 3 square plus 4 square is 5 square, correct? 5 square plus 12 square, 25 plus 144 is 13 square, 169, correct? Pythagorean triplet. Even the third one, 6 square, 36, 64 plus 36 is 100, correct? But which of these triangles among these T1, T2, T3 are related? Will the right triangles be similar? Not all right triangles. Because for the triangles to be similar, the sides should be proportional also. Here 3, 4, 5 and 6, 8, 10. The sides are simply double here. So the sides are proportional. Hence, we have T1 is similar to T3. The triangle with sides 3, 4, 5 similar to triangle with sides 6, 8, 10.